Hey guys, Fro here. Welcome to the channel. So, in one of the recent comments I got on the channel, a user was asking about what a technology stack is. And so, what they wanted me to do was to make a video about a tech stack. What is it? And in this video, we're going to look at what a technology stack is. So, technology stack or tech stack in short. So, to explain what a technology stack is, we're going to use an example. And the example we're going to use is that of somebody trying to travel from one city, one location, and they're going to go to visit someone in another location here. So this could be a very remote location they're trying to go to or over here. And let's just say this is a village. And this is very far. This village is some other side of the world. So this is another continent. So, user on the right side, the challenge or the problem we have is to go visit someone in the village. On the right side, user on the left side. Now, how could they accomplish that to plan out that trip and make that travel happen? The user can say, hey, I'm going to leave my house. In the first leg of that trip, I'm going to use an Uber. For those in the US that are familiar with Uber, it's like a taxi. I'm going to use a taxi. And that taxi would take me uh, to the airport. And once I make it to the airport, I'm going to board a train. Well, I'm going to board a plane, of course. In the airport, you board planes, not trains. I'm going to board a plane, and the plane would take me across the ocean. And so in here is a plane. Now, once you've taken the plane, you can say the plane will take you to a location somewhere, and you would take a train. From the airport, once you arrive at that location here, you take a train to maybe the closest city to your village. Now, once you've taken that train and you've gotten to that city really close to your village, you can say, hey, from there now, you're gonna take a bike or you might walk to get there. So if we look at what's happened here is we've got a goal. Just bear with me. We've got a goal, and that goal. So if we look at what has happened here is we've got a goal, and that goal is to get from one location here all the way to our destination. So this is a problem, or this is a goal. And within this goal, we have many options. We have Uber, we have plane. Let's write this a little bit cleaner. So we're gonna have Uber, plane, train, and walk. Now, this collection of Uber, plane, train, and walk, we can make the argument that this is our solution stack. This is the available set of solutions we have to pick and mix from to solve our problem. So I'm somebody who believes when we talk about tech stack is the way to think about it is, and people get really fancy with this and try to complicate all of this. But at the fundamental level, a technology stack is simply a solution stack. It's a set of options and decisions and tools you put in your tool belt to say, if I'm going to solve a problem, my solution will consist of this, of the options that are available in here. Nothing else. Now, for someone who maybe doesn't like planes for some reason, they don't want to travel in planes, and flying is not going to be an option for them. Their own solution stack might be different. They might say, hey, if I'm going to take this trip, this entire distance from here to here will be done by train alone. And if a train cannot take me to this distance, I'm not going. And for them, a plane would not be an option. So a plane for them will not be part of their solution stack. A plane for them will not be an option for solving the problem. And so this individual, the second individual, would have a stack that consists of just Uber, train, and walk, and that's all they do. And if they have any problem of going from one destination to another destination, if they cannot solve that by Uber, train, or walk, they don't solve that problem. So at a very high level, this is what the solution stack is all about. Now, if we take this and bring this back home with what a technology stack is, or what a tech stack is, which I prefer to call, for me, I prefer a solution stack because it truly describes what it is at the fundamental level. A lot of people, when they hear of technology stack, they start thinking, oh, this technology, that technology, and it just becomes something of a religious thing that people get into. But if you think about it as a solution stack, and if you're trying to build a solution stack, number one is you're going to have to understand the problem. You'll be surprised by the number of people out there who want to solve, who have solutions that are basically looking for problems. And that is going to be a whole debate in itself, right? That these are people who just have technologies out there and they don't have a problem and they start asking, what technology should I use? And to me, I always ask, what's the problem you're trying to solve? If you tell us the problem or you tell me the problem, I can tell you what the technology or what your tech stack would be. So, number one, understanding the problem is really essential. And then number two, having a set of guidelines or principles to go by or constraints. So guidelines could be cost, it could be philosophy, it could be licensing, it could be performance, it could be skill set, and many others. So now, if you understand the problem, let's say you have a problem. Your problem might be to go from one city to another city. Your problem might be to build a website. Your problem might be to build a data science application. Your problem might be to build a gaming website. Your problem might be to do some analysis on finance data. Your problem might be to build a web app, the next web app, and publish on the the Apple App Store. Your problem could be different, but if you understand the problem as a starting point, then you can say, "Hey, this is my problem. I can go out to figure out what tech stack to use to solve my problem. But in order to figure that out, you're going to have to understand the constraints. You're going to have to understand the constraints. You'll be guided by these constraints. We know nobody has infinite cost or the unlimited amount of money or unlimited amount of time. And there are people who have different philosophies. Some people believe that if you want to solve a problem, you should solve it in a way that is environmentally friendly, or you should use a company whose licensing is open source, and you don't want to use a company that doesn't have open source licensing, or you want to make sure that you're picking solutions as part of your stack that perform really well. There might be a tool or a programming language or something in your technology stack that is great on paper, but the performance of it just doesn't allow for your problem. So if you're doing gaming, now you have to think about, if you're trying to choose programming languages, which programming languages really work well for gaming. You're not going to be using Python for gaming. You're going to have to think of something different that is a more performance oriented language. If you're doing data science, you might want to think of a Python because it gives you a vast array of libraries to use for data science. So those considerations have to come into play. And you also have to think about skill set. Do you have the right skill set for whatever thing you have in your tool belt or in your technology stack? So just going back to our example here, if let's say instead of walking here we had biking, so riding a bike or motorcycle, If you knew that you cannot bike, then you definitely are not going to be putting that in your tool belt or in your solution stack or in your tech stack. So that's a choice you have to be cognizant of, understanding the constraint and deciding what makes it into your stack. So all of these constraints, this is a non-exhaustive list, are things that architects or developers or engineers are going to have to consider when building out their tech stack. So that said, with the foundation that we've laid, understanding these two principles. Number one, you really have to understand the problem. I can't tell you how many times people ask questions like, "What tech stack should I use?" or "Which tech stack is the best tech stack?" or "What programming language is the best to use?" And more often than not, almost all the time, my question is, "What is the problem you're trying to solve?" Now, for us in the data analytics space, so for us, I make a lot of videos. I talk about data analytics. So for us in the data analytics space, I'll use that as an example. The pattern that is common is someone wants to um, load data, store data, analyze data, as an example. So if we think about one, load, store, and analyze, what tools can you use in this, or what would the tech stack for solving a problem like this look like? So you might be a retail company, a healthcare company, and you're doing analysis for that team, and you're trying to build a tech stack and say, hey, what are the options that we have for loading data? You might look at either some options. You might say, hey, we're gonna do ETL and talk about the patterns. So you might say, for this, we're gonna do ETL, or we're gonna do ELT. And in here, you can say, hey, we're going to do ETL, ELT, we're going to use streaming. And with streaming, you might say you're going to use Kafka. And that will be part of your tech stack. For storing data, you might say, hey, we want something that is in the cloud. So let's highlight Kafka here. Kafka is a tool in the tech stack. I'm going to name the considerations before we get to the tool. So you might say, hey, we want something in the cloud. We want something which is simple and elastic to store that data. And here you might conclude to say, in our stack, we're going to use Snowflake. And then for reporting and visualization, you might say for your consideration that you want something which is has graphs, something with embeddable widgets. And you might say in here, you're going to use Tableau as part of your tech stack. So building a tech stack for a fictional company here. So in this case, we have a tech stack. We have some options. So very similar to the options we had here for traveling to a new city. In this case, we've developed a tech stack. Really simple one, nonetheless, given our considerations and constraints. So to load data, you say if that data is streaming data, we're going to use Kafka. And you might decide to say, hey, if it's not streaming data where Kafka is not an option, we can use an open source tool. You can say you can use an open source tool or open source software. And there are lots of open source softwares out there that are as an option. And you might decide to use open source software. Why? Because of licensing. You might want to monetize. You might want to take this product and commercialize it. And the last thing you want to do is maybe use .NET. You might say, hey, we're not going to use .NET in our infrastructure, hypothetically here again, because if we use .NET, there's going to be some licensing costs and we're going to have to pay for that. And you might say, we don't want that. Another consideration that you have to figure out, right? Whereas a company that is already embedded into Microsoft, as an example, might say, hey, we're going to do everything here with a .NET type of tool, or we're going to use SSIS, or we're going to use Azure Data Factory. And their own stack might consist of products or solutions coming from Microsoft ecosystem. right? So one other person might consider all open source, somebody might consider Microsoft, some might consider solutions coming from AWS of the world, and they make those decisions based on the constraints that they have and the unique considerations which will be different for every single company, every single individual. So the considerations that you make for your own team and your own stack will be completely different than what somebody else down the line will make. Um, so if we go ahead and we cancel this, that's for loading data or ingestion. For storing data, we might talk about here looking at something like Snowflake, which is elastic. It's cloud agnostic, so you can run this on any cloud. It's really kind of the marquee or the standard, the de facto standard for storing data in the cloud. It's simple, it's easy to use, utility-based model, and many things that make Snowflake great. And you might decide that um, for storing data, you're gonna use Snowflake. Now, there might be other considerations that you might have to say, hey, if you want something open source, or you don't want a database in the cloud, which I don't see a reason why you wouldn't want that. You might want to go with a different database, or you might want a graph database instead of just an analytical platform. So, depending on your considerations, you might want to change the options that you have within the stack. And if you go down the list to the far side, here is for reporting and visualization. Tableau here is an example, but you might say for your own use case, maybe Tableau is not going to work because your company doesn't have a good relationship with Tableau, and you might say, hey, you're going to go with Power BI, use it as such, right? Or you might say you're gonna go with something else, K9, depending on what you're trying to do. So many reporting options are available out in the market. Again, depending on your considerations and the constraints you're working within, you can pick the tools to put in your tech stack. So this is a quick example. Now, this could be a hypothetical tech stack for analytics. Now, if you think about people who are building websites, they might have their own tech stack could be different. If I was doing website development and I'm building a tech stack, my tech stack could be different. I might be thinking about server infrastructure. I might be thinking about databases. I might be thinking about application server, app server. I might be thinking about front end. I might be thinking about APIs. So in servers, you might be thinking of Windows or Linux. Databases, you might be thinking about what kind of databases to store data from your application. Snowflake could be one. You could be thinking about MySQL or any database out there. For the app server, you could be thinking about Apache Tomcat or IIS from Microsoft or some other server infrastructure to use. For the front end, here you're looking about JavaScript, or should you go with a framework like uh, Angular or React for your front end, and the API layer, you're thinking about what options you want to choose there. At each of these options, you predefine the tools that you would be able to use. And once you've defined that tool, it becomes your stack. So if a new developer comes into the team and they are trying to store data into a database, they are not going out to decide if should they use MySQL or should they use Snowflake. That question becomes a mute point, because if you've ruled out MySQL and they should be using Snowflake, now they just go to the stack and say, for our stack, we've chosen Snowflake, and this is why everybody told the line use Snowflake. And it allows you to scale, it allows you to perform, and it allows teams to be, frankly, to be efficient. Having a tech stack to go by, because otherwise you're basically reinventing the wheel every single time. And teams cannot afford to make simple decisions like this every time they run into a problem. But if you have a tech stack, that way you can really architect into the future, knowing exactly what options are there and the considerations you've made that works for you and that works for your business. All right. So hopefully this was helpful answering this question. What is a tech stack? What is a technology stack to say? And just to kind of summarize this, I would always phrase questions like this: is what is a solution stack? Because ultimately, technology stacks are just problems looking for solution. But if you have a solution, you can always map back and triangulate to say, this is the problem I'm trying to solve. I'm looking for a solution to that problem. And as part of looking for that solution, if you understand the key considerations, and architects would help do this, engineers will help do this. You understand the problem and the constraints. You have to understand the constraints you're working with within your organization. Then you can go out to make choices and pick the tools that fall into place to build up your tech stack. Now, once you have a tech stack, you can reuse that, you can plan around that, you can have frameworks around it, you can have development really being efficient because people are not reinventing the wheel every single time. So a majority of the companies out there, the Facebook and the Google, LinkedIn, you name it, they have technology stacks. And the first thing that people want to understand is, what's your technology stack? How do you do stuff? How do you develop? What tools do you use? And based on that, you can say, hey, is this a good fit for me or not? You might go to a company that's pure open source and they're not going to use any vendor product. And you might say, I probably don't want to work for open source companies. That's a choice you have to make. Or there might be companies that say, our tech stack is to be ultimately simple. We don't build, we buy. And if they run into anything where they have to build something and engineer something, they go out and buy that. Again, those are considerations that all have to be made as part of deciding what the tech stack is. So hopefully this was helpful. The question I have for us is, do you know what tech stack your company uses and why? If you know, if you do, leave that in the comment section below. As always, you have been very awesome watching to the end. I have been through. Thanks for watching. I'll see you in the next video.